Okay, so time to talk about our last way to solve equations. Now, technically, this comes before quadratic formula, but way back before we had calculators and we had to do all of that quadratic formula calculation by hand, there was a process developed called completing the square. And basically, that just made the problem easier so they didn't have to do as much work when they were doing quadratic formula. So we're going to talk about completing the square. It's not my favorite method to use, but I think there's a little bit of helpfulness in it. Also, it's another way to convert from standard form to to vertex form. So if you remember at the beginning of the chapter, we talked about vertex form first, where we found our vertex and had it in that parentheses. But standard form, remember, didn't have the parentheses. And this is also a way that you can take your problem from standard form to vertex form without using that negative b over 2a formula. So let's talk about completing the square. So the whole point or the whole idea of completing the square is that we are going to create a situation where we can make one side of our parentheses a perfect square trinomial. So if you remember back when we did factoring, we talked about those special cases. Like what if I had x plus 3 squared or x minus 3 squared? And what did that look like when I FOILed it out? Or if I had x squared plus 6x plus 9, did you remember that that factored into x plus 3 squared? So we're going to basically go through this completing the square process to make one of those perfect square trinomials, which is then very easily factorable. And it's factorable into something squared. So we can undo that squared then by taking the square root. So let me talk real quick first about the actual process of completing the square. So this gets its name by taking the terms that you have, arranging them in a square fashion, and figuring out what linear or what constant term is missing from that value to make it a full square. So here's my example. If I had x squared plus 8x, that gives me 1x by x squared. That's the blue square, so that's my x squared term. And then 8, 1 by x rectangles. So 1 by x, 1 by x, 1 by x, and there's 8 of those. That's a big old rectangle. If I wanted to make it a square, I could take those 8 green rectangles and I could divide them in half. And so I get 4 rectangles off to the side and 4 rectangles down. I still have x squared plus 8x. They just look different. Okay. And when I do that, I make a square with some parts of that square missing. So I'm trying to think to myself, okay, well, what would fit in here? How could I fill in that square? Well, if you think about it, you notice there are 4 squares by 4 squares. That's 4 times 4. So if I wanted to fill in that section, then I would get 4 times 4 single constant units. So that would make 16, 4 squared, 4 times 4. So that gives me that perfect square trinomial of x squared plus 8x plus 16, which we can easily factor. And that's the whole point, is we're trying to figure out, okay, what magic number will we get these yellow units so that I can go through and make that easily factorable equation. Okay. So again, why are we doing this? Well, first we want to make it easily factorable. That way we can solve it. This was an alternative, remember, to completing the square. Sorry, to quadratic formula. And we can also use completing the square to change from standard to vertex form. Okay. All right, so what are the steps for completing the square? Can you lay them out for me, basically, is what we're trying to think about here. So here we go. First of all, these are equations. So if I do anything to one side, I'm going to need to make sure that I add it to both sides or subtract it from both sides. So I need to make sure that I do that properly. Otherwise, it's not an equation anymore. Okay. When we do completing the square in this class, we will have two kinds of problems from the start. We might have an x squared plus a number x equals a number, or we might have the x squared term all equal to 0. When we do that, the whole idea is that we want the x squared and the x term on the side by itself before we do the completing the square. So if we're going to start with this kind of problem, we need to move d to that other side. So now they would look the same. Okay. Now we're going to go through and we're going to find what I call the magic C value. And that magic C value is basically those little yellow squares up here. So this part that's circled, that would be my magic C value, or the amount that it would take to complete the square. So when we go to complete the square and find that magic C value, we're going to take the b over 2, so the b term, the middle term, divided by 2. Remember, that's how we got these two green sections. So that middle term divided by 2, and then we're going to square it. So our step here would be find the C value and square it. Find the C value and square it. So I forgot my square root on both of those. Sorry about that. So we're going to find that magic C value by taking that middle term and squaring it. Then we're going to add it to both sides. Remember, we want it on the left side with the x term so that that side's really nicely factorable. And we have to add it to both sides because it's an equation, and I can't just add things to one side. So I'm going to go ahead and add that magic C value to both sides. Then I'm going to factor my left side, which will be really easy. Do any arithmetic on the right side. So basically simplify everything. Now I'll have something squared, so I get to take the square root. And then if I need to, I will add and subtract to get x by itself. So let's take a look at what that looks like in our problem. So if I start out with x squared minus 18x equals negative 28, the first thing I have to think is, okay, this is my partial completing the square product. So I need to figure out what do I add to make that a very nice, pretty square. If you think about it in the terms of our visual there, that tells me I have 1x squared, and then I have 18 little squares. So basically, I would have 18 of those rectangles, right? So the first thing I'm going to do is chop those rectangles in half, and I'm going to have my x squared term, and then I'm going to have rectangles across and rectangles down. And half of 18 is 9, right? So over here, you can see I took my 18 and I divided it by 2. That gave me 9. And then I'm going to square that value and get 81. Yes, keep your sign with it, but then when you square it, it's going to end up being a positive number. That is good, but you need that minus 9 because I'm going to refer back to it in a minute. So I'm going to take that negative 18, divided by 2 to get negative 9, and then square that, and that's how I get 81. So then you'll see I took that 81 and I added it to both sides. Remember, I want to add it to the left side so that that's nice and factorable. And I have to add it to both sides because it's an equation. So I go through, I have x squared minus 18x plus 81 on the left side, and then I simplified negative 28 plus 81. That's how I got my 53. This x squared minus 18x plus 81 is one of those perfect square trinomials. So it should factor to x minus 9 squared. Now, if you think about this, this is always going to happen. Remember that minus 9 we had before? That's going to show up again in your factor. So really, you shouldn't have to think too hard about what that factor is going to be because you already found the number that goes in that factoring. So I have x minus 9 squared, again, equals 53. And the idea here is I want to get x by itself. So let's undo the squared by taking the square root of both sides. Now, when you take the square root of a squared, those both go away. So I just have x minus 9. Square root of 53, that's not a nice number, so I'm just going to leave it as the square root of 53 right now. Now I have x minus 9 equals a square root, and then I'm going to add 9 to both sides to get that x by itself. So my final answer here is x equals 9 plus or minus the square root of 53. Okay. So that would be my completing the square answer. And if I did quadratic formula, it would simplify to something very close to this. With my square root if I was doing it by hand. And then if you type that in your calculator, you'll get the same decimal answer as if you had done quadratic formula with the original problem. Okay. So let's take a look at another example and just go through those steps one more time. Remember, this one is equal to 0. So the first thing I need to do is get this 24 over here so that I can do my completing the square. So I'm going to subtract 24 on both sides, and now I have n squared minus 10n equals negative 24. That's definitely what I want so that I can complete my square on this side. So then I got to go through and find that magic C value. So you'll see over here I took my negative 10, divide by 2, squared it. Remember, negative 10 divided by 2 is negative 5. Negative 5 squared then is 25. So that tells me I need to add 25 to both sides. So on the left side, I get n squared minus 10n plus 25. And then, of course, over here, I combine those like terms, and I got 1. Okay? So go through, and n squared minus 10n plus 25 is one of those perfect square trinomials, and it makes n minus 5 squared. Remember that minus 5 came from when you did negative 10 divided by 2. Take the square root to get rid of that squared term. Of course, the square root of 1 very nicely ends up being 1. So I have n minus 5, equals plus or minus 1. I'm going to add 5 to get n by itself. So if I have 1 plus 5, that makes 6. If I have negative 1 plus 5, that makes 4. So my answer here is 6 and 4. Okay.